Hello Calculus and welcome to 7.6. This is the last section of this chapter. It is on numerical integration. We're going to learn two new rules today, the trapezoidal and the Simpson. So let's get moving. We're going to start with the trapezoidal. All right, so like I said, we have the trapezoidal and the Simpson rule. We're going to start with the trapezoidal, and believe it or not, it's not rectangles this day, it is trapezoids. So we're going to find, I want to integrate, find the area of the curve 1 over x, so a very simple function, from 1 to 5 is what we need to do. And instead of using rectangles, we're going to use a trapezoid. But in order to use a trapezoid, you have to remember its formula. So remember, generally a trapezoid would be drawn like this, right? And this is the base, and this is the second base, and this is the height. So to find the area, which is right here, it's 1/2 the base plus the base times the height. Well, here, when we're doing our bases, it's going to be the two sides of a trapezoid, all right? And our height is going to be the width of our trapezoids, which will be the same all the way through. So now when we plug in 1, 2, 3, 4, and 5, we actually have to do that first so we can figure out our areas of our trapezoid. So when we plug into 1 to 1 over 1, we get 1. This one here is 1/2. Plug in 3 for x and you get 1/3. 4 for x, you get 1/4. And 5 for x, you get 1/5. Now we have to find the area of all those trapezoids and add them up. Well, I'm going from 1 through 5, and I'm having 4 trapezoids, so my width is 1 this time. Okay, I hope you're doing well so far. Now, all we do is we add them up. First, though, I wanted to show you the fundamental theorem of calculus, just so you remember. So if I want to find the integral from 1 to 5 of 1 over x, remember the integral of 1 over x, or the antiderivative, is the natural log of x from 5 to 1, and our area is 1.60943. Let's see how close our trapezoidal rule is. Now, I'm going to show you the long way, and then we're going to shorten this dude up. So I'm going from 1 to 5. Okay, so I have 1/2 first. So remember, our first side was 1. So this is our base and our base. So 1/2 base plus base times height. And these 4s were supposed to be 1. So please fix your notes. So it's 5 minus 1 divided by 4, which is 1. All right, so we get rid of those. So, and we take that times 5 minus 1 over 4. And then it's 1/2. The second one, now we're going from the 1/2 to the 1/3 up here, times your width, 1/2. Now you're going from the 1/3 to the 1/4, times your width, 1/2, 1/4 to the 1/5, times your width. Now, let's distribute these halves all the way through. I have this for every single one, correct? So I'm just going to factor 5 minus 1 over 4 out. All right, so now I just have my parentheses left. So we got 1/2 plus 1/2 times 1/2, 1/2 times 1/2, 1/2 times 1/3, 1/2 times 1/3, 1/2 times 1/4, 1/2 times 1/4, 1/2 times 1/5. Look what happens here. We are taking a half times a half twice, right? So if I have 2 1/2s, that actually gives me half. And then I'm doing the same thing here. I have a half times 1/3 twice. So 1/2 plus 1/2 is 1/whole third. And the same here, a half times a fourth twice. So that gives me 1/4. I only have a half of a fifth and a half of 1. And that's the trapezoidal rule. It's your width of your trapezoids, half the first term, then the second term, third term, fourth term, all the way up until you have half the last term. Add those up, and we get 1.68. So it's a little above where we wanted to be, but not bad. All right, so the trapezoidal rule written out. So I'm taking the integral of f of x, so it's b minus a, my top minus my bottom, divided by how many trapezoids I want. 1/2 the first term, 1/2 the last term, and we add all the in-between terms up. And that's called the trapezoidal rule. Okay, let's go down here and try ours. So now I want to go 0 to 2. I want 4 rectangles. So I have to take 2 minus 0 and divide it by 4. which is equal to 1/2. So I know every half I have a new rectangle, and I have to figure this out before I can do anything. So I take the square root of x squared plus 1, my function, and I'm going to plug in all these things. So my first term is 0. Okay, I would call this my first term. That's okay. Second is 1/2, 1, 3/2, 2. Now I'm going to plug 0 into my function. So the x squared plus 1 square root. So 0 plus 1 square root is 1. 1/2 squared plus 1 square root is 1.1803. And we just continue down. 1 squared plus 1, so square root of 2. 3/2 squared plus 1 square root 1.8. 2 squared plus 1, so square root of 5. That gives me the height of my sides, and that's all that does. So I know by my trapezoidal rule, I'm going to take 2 minus 0 divided by 4. This is my width. Half of the first term. Oops. Come on, right. There we go. Half of my first term. My first term is 1. So I'm going to take 1/2 of 1 plus all the in-between terms, the 1.11803 plus the 1.4121 plus the 1.8027. The 2.23 is my last term, so I have to take half of that. I just type that in my calculator. My area is 2.97653. All right, pause and try yours. Make sure you take your time. Step 1, you had to figure out your width. So we know my width is equal to 3 minus 1 divided by 4, which is 2 over 4, which is 1/2. So the table I have to do, I have to plug in 1/2. All right, it goes by 1/2. So I'm going to start at 1, then 1.5, then 2, then 2.5, and then 3. And that's going to give me all of my sides, or my bases for my trapezoids. So now you have to plug 1 in to your square root of 1 squared plus 3. So you know the square root of 4 is 2. Oops. Then we got to plug in the 1.5. And you should have gotten 2.29129 square root of 2 squared plus 3, or the square root of 7. You should have gotten 2.64575. If you round too soon in this, you'll get the wrong answer. So always go out at least 4, but preferably 5 decimals. Now you do the square root, 2.5 squared plus 3. And that equals 2.69258. And then the square root of 3 squared plus 3, square root of 12, which is 3.4641. All right, now we need to find our trapezoidal rule. Our trapezoidal rule is you take our width, which is the 3 minus 1 over 4, or in other words, 1/2. So this is the width times all of my stuff. So first one is, change colors here so you know we're on this guy. So we're starting with 2, so it's 1/2, the first term, plus all the middle terms, 9129 plus 2.64575 plus 2.69258 plus half of your last term, 3.4641. All right, now you should take all of this, type it in your calculator, and I got approximately 5.1808. And that's the area underneath this curve and the x-axis. Okay, trapezoidal rule. Next, let's go on to our Simpson rule. All right, uses 3 points on the curve to create a parabola to estimate the area. Okay, so this is very different. So you got a curve and it picks 3 points on those curves to create a parabola to make it close, is what it's doing. So if I got this curve it's going to take, and I want to go from, let's say, here to here, it's going to take 3 points. And it's going to guess what those areas are. So let's show you how this is done. Here's my function, d of x. It takes b minus a and it divides by 3n. All right, n again is the equal number of how you want to divide up your little parabolas that you're creating. So it's the first function as is, plus, and then it alternates 4 times 2 times 4. All right, so it's 4 times the next one, 2 times the next, plus 4 times the next. It continues that pattern until you get to the very end one, and then that's itself. So first is left alone, second's left alone, 4, 2, 4, 2. This time it's b minus a over 3n because it's doing 3 points. All right, let's try this guy. Same problem, but Simpson's rule. So n equals 4 again. Okay, so you know a is 1, b is 3, n is 4. We have to make our endpoints. So we do, you know, it's 3 minus 1 divided by 4, which is 1/2. So every half is where it changes again. We start at 1, 1.52, 2.53. All right, we plug those into our equation. We get 2, 2.9, 2.6, 3.0, 3.46. Nothing new yet, right? Now, when you add the Simpson rule to it, it's 3 minus 1 over 3 times 4. This 3 is different. All right, we bring down the first one, which is 2. We take 4 times the second one, plus 2 times the next one, plus 4 times the next one. I'm at the end one, so I leave it alone. First and second do not change. Put that in your calculator and you get 5.3477. Okay, pause and try yours. So now again, n equals 4, so you should have taken 2 minus 0 divided by 4. You know you're going by halves. So in your little table, you should have started at 0, went up by a half, 1, 1.5, and 2. Typed all of those into your formula, square root, plus 1 squared equals 1 square root, I squared it now, 0.5 squared plus 1 equals 1.11803. Plug in 1, square root, 1 squared plus 1, or the square root of 2. You get 1.41421. Lines are not very crooked, not very straight. Plug in square root of 1.5 squared plus 1. You get 1.80278. Plug in your 2. 4 squared plus 1, or the square root of 5, and you get 2.23607. Okay, applying the Simpson's rule. Now, so when you do that, we start with 2 minus 0 over 3, always 3, remember 3 points that we're averaging, times the number that we're doing, number of parabolas. So now we take this, and it's the first term as is, so that's 1 plus now 4 times the second term, plus 2 times the next term, plus 4 times the next term. Okay, plus, I'm out of room, the last term as is. Remember, first and last day. Okay, plug all that into your calculator, and we get approximately 2.95795, or whatever you feel like rounding to, since I didn't tell you. All right, so that's known as the Simpson rule. All right, let's see if we can figure out something to do with this. Okay, total distance. So velocity gives rate of change of distance with respect to t. Now suppose a vehicle travels an unknown distance, so we don't know what that is. A passenger keeps track of the velocity every 10 minutes, so they're doing the math for us, for 1/6 of an hour, with the following results. What's the total distance traveled? All right. So in 1/6 of an hour, the velocity is 45. At 2/6 an hour, it's 55. At 3/6, they're going 52. 4/6 of an hour, they're going 60. 5/6 an hour, they're going 64. 1 hour exactly, they're 58. 1 hour and 10 minutes, or 7/6, they are at 47 miles per hour. All right, let's look at our formulas here. We know distance traveled in t hours, so st. Okay, so that means the derivative of distance traveled is our velocity. So to find the total distance traveled, we take 1/6 to 7/6, so our 10th, to our 7/6, an hour and 10, of v of t dt. So we have to take 7/6 minus 1/6, where we end where we start, 6 times and 3 times that, because this is the Simpsons rule. We leave the first guy alone, and it's 4 times the 55, 252, 460, 264, 458. Leave the last one alone. Type that in, and our average velocity, our speed, is 56.44 miles per hour. Not bad, right? Okay, you do the exact same problem, except I want you to use the trapezoidal rule with the above data to calculate the distance. The actual distance is 56 miles. So this guy right here is over by 0.44 miles. Which method's more accurate is what I want to know. In this instance, it's not always the same. So pause and try yours. So again, your integral was from 1/6 to 7/6. Okay, you're doing the velocity, and it's going to equal to, so top minus bottom, all divided by 6, because we are divided into 6 things. Now remember, trapezoidal is 1/2 the first, plus all the middle terms. So you're 55, you're 52, you're 60, you're 64, you're 58, and then half of the last term again. If you type that all into your calculator, you should get 55.83 miles. So in this instance, the Simpson rule is better than the trapezoidal rule. All right, you do not have a lot of homework. There's only like 4 or 5 problems. They just take a long time. Please be very, very careful with your signs and your adding. Good luck, and make sure you post questions if you have any.